Alright, so in this problem, I have 3 to the power of x is equal to 80. So, I want to find the value of x here. So for my solution, I first start with 3 to the power of x is equal to 80. And now, I'm going to take the log on both sides. So I get log 3 to the power of x is equal to log 80. Now, we want to find a way to, we want to find the value of x, right? And to get x, it's hard to do it when it's in exponent form. So we want to find a way to bring x down to make it a real term. And to do that, there is an important property of logarithms that states that if there's something in the form log a to the power b, I can move this x1b to the front. So this is going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So now I have x times log 3 is equal to log 80. Now from here, I'm going to rewrite 80 here as 8 times 10. And if I have something in the form log a times b, this is equal to log a plus log b. And this is another one of the logarithmic properties. There is also log a over b, and if I have something in this form, this is the same thing as log a minus log b. So now going back to the problem, we have log 8 times 10, and we can use this property. So we can think of 8 as a and 10 as b. So this is going to equal x log 3 is equal to log of 8 plus log of 10. Now, if you guys already didn't know, log 10 is simply equal to 1. So I get x times log 3 is equal to log 8 plus log 10. Or sorry, just 1. And now remember, we want to isolate x, so the only thing left to do is to get rid of this log 3 by dividing both sides by log 3. So then this cancel out, and I get x is equal to log 8 plus 1 over log 3. Now, log 8 is equal to 0.90309, and log 3 is equal to 0.4771. So this is going to equal 0.90309 plus 1 over 0.4771. And this is equal to 1.90309 over 0.4771. Now 1.90309 over 0.4771 is equal to 3.9889. So x is equal to 3.9889. Now, the only thing left to do is to check if my solution here is correct. So the original equation was right here, 3 to the power of x is equal to 80. And my solution is x is equal to 3.9889. So if I plug this in for x into my original equation, I get 3 to the power of 3.9889 is equal to 80. Now 3.9889 is really close to 4, right? So let's first find the value of 3 to the power of 4. 3 to the power of 4 is the same thing as 3 times 3 times 3 times 3, which is the same thing as 9 times 9, which is equal to 81. Now 3.9889 is a little less than 4, meaning we can estimate that it's going to be around 1 less than 81. So it's safe to say that 3 to the power of 3 to the power of 3.9889 is close to the value of 80. Alright, so in this problem, I have 9 to the power of x plus 15 to the power of x is equal to 25 to the power of x. So I'm going to first start by dividing both sides by 9 to the power of x. So now this results in 9 to the power of x over 9 to the power of x plus 15 to the power of x over 9 to the power of x is equal to 25 to the power of x over 9 to the power of x. Now 9 to the power of x and 9 to the power of x cancel out. So I get 1 plus 15 to the power of x over 9 to the power of x is equal to 25 to the power of x over 9 to the power of x. Now, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So 15 to the power of x over 9 to the power of x, that's going to equal 15 over 9 to the power of x. And 25 to the power of x over 9 to the power of x, that's going to equal 25 over 9 to the power of x. And now, 15 over 9 simplifies to 5 over 3. And 25 over 9, that simplifies to 5 squared over 3 squared. So now 5 squared over 3 squared, that's going to equal 5 over 3 squared. Now I have this to the power of x. Now if I have something from a to the power of m to the power of n, same thing as a to the power of n to the power of m. So 5 over 3 squared to the power of x, that's the same thing as 5 over 3 to the power of x squared. Now I'm going to let 5 over 3 to the power of x equal to the variable y. So I get 1 plus y is equal to y squared. And if I subtract y and 1 on both sides, I get y squared minus y minus 1 is equal to 0. So I get a quadratic equation, and to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a times c, which is negative 1, all over 2a, so 2 times 1. This is equal to 1 plus or minus the square root of negative 1 squared, which is 1, minus 4 times 1 times negative 1, which is plus 4, all over 2, which is equal to 1 plus or minus the square root of 5 over 2. Now remember how we let 5 over 3 to the power of x equal to y. So I have 5 over 3 to the power of x equals to 1 plus or minus the square root of 5 over 2. So now this gives me two equations. I have 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2, and 5 over 3 to the power of x is equal to 1 minus the square root of 5 over 2. So 5 over 3 to the power of x equals 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5, that's going to be a negative number. And a negative number divided by 2 is still a negative number. And notice how we have a positive number to the power of another number here. And you can't take the power of a positive number and make it equal to negative. So there is no solution for this. Now for 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. To solve this, I'm going to first start by taking the log on both sides. So I have log 5 over 3 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move b to the front, so it's going to equal b times log a. So in this case, I have log 5 over 3 to the power of x, and I can move x to the front, so I get x times log 5 over 3 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 5 over 3, these two cancel out, and I get x is equal to log 1 plus the square root of 5 over 2 over log 5 over 3.